Now let us have some more problems on Cauchy's integral formula. Evaluate the integral z square minus z plus 1 by z minus 1 dz over a closed curve C. So here there are two cases given. C is a circle mod z equals to, second case C is a circle mod z equals 1 by 2. So now we have to find the value of this integral. So first we have to identify the singular point. So take the given function. So here f of z. So take f of z as the function in the numerator. So in the numerator we have z square minus z plus 1. So now we have to find the singular point. So to find the singular point, this function inside the integral sign, when it becomes infinite, when the denominator becomes 0. So when the denominator becomes 0, it becomes infinite. So z minus 1 equals 0. This implies z equals 1. So here when you put z equals 1, we get 1 minus 1, that is 0. So 1 by 0 is infinite. So z equals 1 is a singular point. So already in the previous video we have discussed about the singular point. Now case 1, C is a circle mod z equals 2. So here first circle is given, first curve is given, that is mod z equals 2, that is mod z minus 0 equals 2. So this equation represents a circle. So it represents circle. Center of the circle is 0 comma 0 and radius is 2. So now first we have to draw the figure. So draw the figure of this circle. Center is 0 comma 0, that is origin. This is the center 0 comma 0 and radius is 2. So radius of the circle is 2, that is, so the point on the x-axis is the real axis and the y-axis is the imaginary axis. So the point on the x-axis is 2 comma 0, to the left side it is minus 2 comma 0. The point on the y-axis it is 0 comma 2 and to the negative side it is 0 comma minus 2. So after writing the figure, now we have to check whether the singular point z equals 1 lies inside this circle or outside this circle. So z equals 1 means it is nothing but 1 comma 0. So z equals 1 means it is nothing but 1 comma 0. So 1 comma 0 lies somewhere here. So this is 1 comma 0 on the x-axis. So since the singular point z equals 1 lies inside the circle, we have to use Cauchy's integral formula. So by Cauchy's integral formula, we have integral f of z by z minus a dz equals 2 pi I into f of a. So what Cauchy's integral formula states? So it states that f of z is analytic inside and on the closed curve C except at z equals a. Then integral f of z by z minus a dz equals 2 pi I into f of a. So here this integral, this function is analytic inside and also on the closed curve C. What is the closed curve C? On the circle. So the given function is analytic inside and also on the closed curve C except at z equals 1. So z equals 1 is a singular point. So now by applying Cauchy's integral formula, integral, so f of z is z square minus z plus 1. We have taken z square minus z plus 1 by z minus a. Here z minus a is z minus 1 dz. So this is equal to 2 pi I into f of a. What is a here? So here a is 1 So f of z is z square minus z plus 1 by z minus a is z minus 1. So a is 1. So this is equal to 2 pi I into f of a. Here 2 pi I into f of 1. So this is equal to 2 pi I into what is f of z. So f of z is z square minus z plus 1. So f of 1 is z square minus z plus 1. So 2 pi I plus 1 minus 1 gets cancelled into 1. So this is equal to 2 pi I. So integral of z square minus z plus 1 by z minus 1 dz equals 2 pi I. Now let us see the second case. C is a circle, mod z equals 1 by 2. So mod z equals 1 by 2 means mod z minus 0 equals 1 by 2. So this also represents circle. Center is 0 comma 0, radius 1 by 2 comma 0. So let us draw the graph. Center is 0 comma 0, radius r is 1 by 2. So the point on the x-axis is 1 by 2 comma 0. To the negative side it is minus 1 by 2 comma 0. On the y-axis 0 comma 1 by 2. On the negative side it is 0 comma minus 1 by 2. Now here also singular point is z. So z equals 1 is a singular point. So for the given function z equals 1 is a singular point. So now check whether singular point lies inside the circle or outside the circle. So z equals 1 means, so this is 1 comma 0. So where it lies somewhere here. So z equals 1, that is 1 comma 0 is outside the circle. So this singular point doesn't lies inside the circle. Therefore here we have to apply Cauchy's theorem, not Cauchy's integral formula, because singular point lies outside. So what Cauchy's theorem says? So if f of z is analytic inside and also on the closed curve C, then Cauchy's theorem states that by Cauchy's theorem we have integral f of z by z minus a dz. This is equal to 0 because singular point lies outside the circle. So f of z is analytic at each and every point which lies inside the circle as well as on the circle. So therefore integral z square minus z plus 1, that is f of z, divided by z minus 1 dz. This is 0. You can directly put 0. So now let us solve one more problem. Evaluate integral 2z plus 1 by z square plus z dz, where for a closed curve C, where C is given by mod z equals 1 by 2. So now here first we have to identify the singular points for this function. So now in the denominator we have z square plus z equals 0. So when this function becomes infinite, when the denominator tends to 0, that is 1 by 0 is equal to infinite. So z square plus z equals 0. So taking z as common, so z of z plus 1 equals 0. So this implies z equals 0 and z equals minus 1. So when this function becomes infinite, when z equals 0 and when z equals minus 1. So if you put z equals 0, 0 plus 0 is 0, 1 by 0 is infinity. So again when you put z equals minus 1, so minus 1 whole square is plus 1 minus 1, plus 1 minus 1 is 0, again it is 0. So z equals 0 and z equals minus 1 are two singular points. So this function has two singular points. Now we can split the denominator as 2z plus 1 by z square plus z dz. So we can write this fraction as integral 2z plus 1 by z of z plus 1 dz. So this is nothing but, so we can split this fraction as integral 2z plus 1 by z in the numerator whole divided by z plus 1 dz plus integral again 2z plus 1, now take z plus 1, 2z plus 1 by z plus 1 whole divided by z dz. So we can split this fraction as 2z plus 1 by z whole divided by z plus 1 dz plus integral 2z plus 1 by z plus 1 whole divided by z dz. So both these equations are same, both these integrals are same. So already we have discussed this in the previous video, how to split this integral. So now here in the denominator there is z plus 1. So z equals minus 1 is the singular point here. So z equals minus 1 is the singular point here. Z equals 0 is the singular point. Now given curve is mod z equals 1 by 2. So this is the circle. It represents circle. Center is 0, 0. Radius 1 by 2. So draw the figure. So center is 0, 0 and radius of the circle is 1 by 2. So the point on the x-axis is 1 by 2, 0 and to the left side it is minus 1 by 2, 0. On the y-axis it is 0, 1 by 2. On the negative side it is 0, minus 1 by 2. Now in the first integral z equals minus 1 is the singular point. So now check whether this point lies inside the circle or outside the circle. So z equals minus 1 means, so z equals minus 1 means minus 1, 0. So it comes somewhere here. So this is minus 1, 0. So it lies outside the circle. So this is a point lies outside circle. So apply Cauchy's theorem. What Cauchy's theorem says? Integral f of z, apply Cauchy's theorem since this point lies outside the circle. So f of z by z minus a dz equals 0. So first integral you can directly put 0 plus, now second integral, singular point is z equals 0. So where z equals 0 lies? So this is z equals 0. This point is z equals 0. So z equals 0 is a point lies, so z equals 0 is a point lies inside the circle. Z equals 0 means it is 0, 0. Z equals 0 means it is 0, 0. So it lies inside the circle. So since it lies inside the circle means the singular point 0, 0 lies inside the circle means the function, this given function is analytic inside and also on the closed curve C except at z equals 0. Except at z equals 0, the given function, the given integral is analytic at each and every point inside the circle and also on the circle. So we have to apply Cauchy's integral formula. So what is Cauchy's integral formula? Integral f of z by z minus a dz equals 2 pi I into f of a. So but what is f of z here? So f of z is the function in the numerator, that is 2z plus 1 by z plus 1. So integral f of z by z minus a dz. So here integral f of z. So this is f of z, 2z plus 1 by z plus 1. That's what we have written here. F of z is 2z plus 1 by z plus 1 by z minus a. What is z minus a here? Z minus 0. Z minus 0 dz. So this is equal to 2 pi I into f of a. So here 2 pi I into, so what is a here? A is 0. That is z minus 0. A is 0. So 2 pi I into f of 0. So this is equal to 2 pi I. What is f of 0? F of z is 2z plus 1 by z plus 1. F of 0 is 2z is 0 plus 1 by 0 plus 1. Z is 0. 0 plus 1 by 0 plus 1. So this is equal to 2 pi I. So the value of this integral 2z plus 1 by z square plus z dz over a closed curve C is 2 pi I.